Hey everyone, welcome back to another new video. In today's video, I am going to solve 0 to 1 knapsack problem. And today's problem of the day is very common question. You can see already Flipkart, Amazon, Microsoft, many popular company ask this type of question in interview. So before starting today's video, please like and share. And if you are new, please subscribe. Go to problem statement. In problem statement, you have given a weight and values of items and put these items in a knapsack of capacity W to get the maximum total value in the knapsack. Okay, and note that we have only one quantity of each item. We have only one quantity of each item, and in the other words, given two integer arrays, one is one is variable or value, and another is weight, which represent the values and weight associated with the items respectively, and also given an integer w which represent knapsack capacity. Find out the maximum sum values subset of val such that the sum of the weight of the corresponding subset is smaller than or equal to w. Okay, you can't break an item, either pick the complete item or don't pick it. 0 to 1 property means we have given a maximum weight, we have given a weight value, and we have to maintain using so that from between this weight value we have to pick the profit with weight value, which will be this value equal to, or it is less than or equal to this given this weight value. You have to find that value. So that's it. Understand it. Example. In given example, given weight is w equals to 4. Okay, or means we have to find from this variable and weight value which are equal to or less than, equal to or less than this 4, equal to or less than 4. We have to find that value. Okay, and in this variable, our value is in value variable, given value 1, 2, 3, and in weight variable given elements are 4, 5, 1. Okay, and in this, for weight 1, for weight 4, what is our variable? 1, 1. Okay, this one for 1, write down here. For 4 variable is 1, and for 5 variable is 2. For 5 variable is 2, and for 1 weight 1 variable is 3. For 1 weight is 3. Okay, now we have to find which is our maximum element and which also maintain the given weight value 4, which will be less than 4 or equals to 4. And in given, you can see for weight 1, if we pick 1 and our variable value is 3, value is 3, and this 3 also less than 4, this 3 also less than 4, so we satisfy our condition. So our maximum value in output will show, 3, it will be 3. Okay, now go to next example. In next example, given input is variable input is this 1 2 3 and weight is 4 5 6. Okay, in this for 1 our weight is 4, and for 2 weight is 5, and for 3 weight is weight is 6. Okay, and if we pick one, in that case it will be 4. If we pick a variable 2, it will be goes to 5, and if we pick 3 it will goes to 6. If we pick 3 it will goes to 6, and our given weight maximum we have to find less than or equals to 3. So in this case, if we pick one variable 1 and it is weight is 4, but it is greater than our given weight, so it will not consider. And go to next. if we pick well 2, weight is 5, and 5 is greater than our given weight 3, so it will not again considered. If we pick 3, our weight is 6, and 6 is also greater than 3, 6 is also greater than 6, so it is not considered. So any of these is not considered because both are greater than our given weight value. So in this case, output will show 0. Output will show 0 because we can't find any match value which are equals to or less than this value. So it will be 0. And so for this, what we in code do? In code, basically we use a dynamic programming table, and first we initialize a dp table to 0. First we initialize dp table to 0, and then we fill the dp table, and after filling the dp table, we'll create a for loop. We'll create a for loop, and this for loop will go to from 1 to n plus 1. It will go to 1 to n plus 1, and after that we create a condition. This loop will containing if using this condition, and our condition is if weight if weight is less than or equals to, if weight is less than equals to given weight. If our when we traversing the elements, if that weight is less than equal to our given fixed weight which are given, it means if this given weight, sorry, this given weight, if this given weight is when we traversing the variable, all the variable input value and weight value, and if this value is less than or equals to this value, then it will goes to this condition. So we create this if condition. If weight I minus 1 less than equals to our given weight, and it will go to this dp I w, and containing this a condition, and then else it is if it is not satisfied this condition, then it will goes to dp the I w go to I minus 1 dp I minus 1 w. If it is not satisfied, it is else, okay. And at the last stage it will return the last stage it will return, okay. Okay, I will clear. I think it is easy. Then for that I will remove it, and I know you understand what is if condition, and if it is not satisfied, then it will else continuing this, else it will goes to like it will go to dp, and traversing the element and weight value, and it will be goes to dp I minus 1, and w go to this else. This is else, and after that it will return, basically it will return dp n and w, dp n and w, n and w which are matched less than equals to our given weight. In the last line it will return this. And what is the time complexity and space complexity of this? Time complexity will be O of big O of n n into n into w, and space complexity also big of n into w. Both are here. N is the number of the elements, and w is the weight, okay. So both are same, n into w. Now compile the code, and this code I also write down the comment for your better understand. And you can see we create, first we initiate check the length of the variable, this check this length of the variable. Okay, after that we initialize dp table with zeros, and after initializing, it will fill the repeat table using a for loop. And our condition is this: if wti minus 1 less than equals to w, then it will continue this, and else it will continue this. And in the last line we will return the last cell which contains the maximum value. Okay, which contains the maximum value. That's it. Now compile and run. Now submit. Okay. Okay. We solved today's problem. Hope so today's video is helpful to you. See you next videos. Till then, tata bye bye.